The discovery of Pluto is an intriguing story that spans decades, involving the work of astronomers, advances in technology, and a bit of serendipity. Here's a detailed exploration of the events surrounding the discovery, beginning with the scientific context of the time and concluding with the significance of Pluto in modern astronomy. By the early 20th century, astronomers had catalogued the planets of our solar system, from Mercury to Neptune. However, the discovery of Neptune in 1846 sparked a curiosity about the possibility of another planet beyond it. The reason for this interest stemmed from the observations of irregularities in the orbit of Neptune that hinted at the presence of a larger, unseen planet exerting gravitational influence. Astronomers like Percival Lowell, in particular, became fascinated with the idea of this hypothetical ninth planet. Lowell, founder of the Lowell Observatory in Flagstaff, Arizona, took the lead in searching for this unknown object, which he called Planet X. Lowell based his predictions on his calculations of the orbit of Neptune and sought this elusive planet by mapping the sky. In the 1910s and 1920s, Lowell's observations and predictions led to a widespread belief in the existence of Planet X. He suggested that this planet was far beyond Neptune and was large enough to cause disturbances in the orbits of the known outer planets. However, despite several years of searching, Lowell's telescope never found Planet X. The search for Planet X remained a topic of interest into the 1930s, despite Lowell's death in 1916. In 1929, the Lowell Observatory hired a young astronomer named Clyde Tombaugh to continue the search. Tombaugh, who was only 24 years old at the time, had demonstrated his skills in astronomy by creating hand-drawn sketches of the night sky using his own homemade telescope. Tombaugh's job was to carefully scan the sky for the elusive planet. He began the task of examining photographic plates, which were taken using the observatory's large telescopes. These plates were images of different sections of the night sky taken a few days apart, and Tombaugh would compare them for movement, the telltale sign of a planet. In order to systematically search the sky, Tombaugh used a technique called blink comparison, in which he would place two photographs of the same part of the sky, one from a few days earlier and one from a few days later, in a device called a blink comparator. This device allowed him to flick through the images rapidly and watch for any moving objects, which would indicate a planet or a comet. Tombaugh spent months examining thousands of photographic plates. His efforts were painstaking and methodical, and he reviewed large sections of the sky in the hope of spotting something out of the ordinary. On February 18, 1930, his hard work finally paid off. Tombaugh discovered a moving object in the images, something that did not belong to the fixed starry background. It was faint, but unmistakable. This object was the long-sought Planet X, but it was much smaller than had been expected. Once Tombaugh had found the object, the next task was to confirm its identity. The discovery was initially a bit of a mystery because the object was smaller and less luminous than the expected giant planet. Nevertheless, astronomers quickly began to study it further. The discovery was announced on March 13, 1930, in a press release by the Lowell Observatory. The object was initially referred to as Planet X, but it soon became clear that it was something different. It wasn't a large gas giant like Jupiter or Saturn, but a much smaller and icy world located far from the sun. Following the announcement, the object needed a proper name. There was a great deal of public interest in the discovery, and many names were suggested. The winning name was proposed by an 11-year-old girl named Venetia Burney, who had been studying classical mythology. She suggested the name Pluto, after the Roman god of the underworld. The name was fitting, given the planet's dark, distant location in the solar system. Burney's suggestion was quickly adopted by the scientific community, and on May 1, 1930, the object was officially named Pluto. In addition to the name, the new planet received the symbol, derived from the first two letters of Pluto's name and a nod to the letter P, the initial of Percival Lowell's name, who had initiated the search for Planet X. After the discovery, astronomers turned their attention to the characteristics of Pluto. Early observations suggested that Pluto was quite distant from the Sun, with an orbit that took it far beyond the orbit of Neptune. The object was initially thought to be a planet, but over time, astronomers began to realize that Pluto's orbit was highly eccentric, meaning it did not follow a simple circular path like the orbits of the other planets. One of the most puzzling aspects of Pluto was its size. Initially, it was thought to be roughly the size of Earth, but further observations revealed that Pluto was much smaller, about 1/6 the size of the Moon. By the 1940s, astronomers were reconsidering Pluto's classification as a planet, as its size seemed more in line with that of a large moon than a full-fledged planet. Throughout the 20th century, Pluto continued to be a subject of intense study and debate. It was too small to be classified as a major planet, but its distant location in the solar system and its unusual orbit kept it at the forefront of astronomical research. There were also occasional discoveries of other objects in the outer solar system, some of which seemed to resemble Pluto. This prompted questions about whether Pluto was unique or part of a larger population of similar objects. In 2006, the International Astronomical Union, IAU, made a significant change in how it classifies objects in the solar system. This was the year that Pluto's status as the ninth planet was officially challenged. The issue arose with the discovery of a number of similar-sized objects in the Kuiper Belt, a region beyond Pluto that is populated with icy bodies. One such object, Eris, was discovered in 2005, and its size and location were very similar to Pluto's. This sparked a debate about whether Pluto should still be considered a planet, especially since these newly discovered objects were also large and had similar orbits. The IAU convened to define what constitutes a planet, and their decision was to exclude Pluto. In order to be classified as a planet, an object had to meet 3 criteria. It must orbit the Sun, it must be massive enough to assume a nearly round shape, and it must have cleared its orbit of other debris. While Pluto satisfied the first 2 conditions, it failed the third. Its orbit is shared with other objects in the Kuiper Belt, which led the IAU to reclassify Pluto as a dwarf planet. This decision was controversial and has remained a point of debate among astronomers, planetary scientists, and the general public. Some argue that Pluto should still be considered a planet due to its unique characteristics, while others accept its new classification as a dwarf planet, acknowledging the growing understanding of the complexity of the solar system's outer regions. Despite the controversy surrounding Pluto's status, the object continued to intrigue astronomers. In 2015, NASA's New Horizons spacecraft made a historic flyby of Pluto, providing the most detailed images and data about the dwarf planet to date. The spacecraft had been launched in 2006 and traveled over 3 billion miles to reach Pluto in 2015. New Horizons sent back stunning images of Pluto's surface, revealing vast plains of frozen nitrogen, towering ice mountains, and a complex, layered atmosphere. These discoveries shed new light on Pluto's geology and climate, challenging previous assumptions about its composition and history. The mission also revealed that Pluto is far more active than previously thought. It showed evidence of geysers of nitrogen gas erupting from beneath the surface and an interior that may still be warm. These findings sparked a renewed interest in Pluto and have led many scientists to consider it a more dynamic and interesting world than they had ever anticipated. The discovery of Pluto marked the end of an era in astronomy, as it was the last planet in the solar system to be discovered. It also served as a reminder that our understanding of the solar system is constantly evolving. From its discovery in 1930 to its reclassification as a dwarf planet in 2006, Pluto has remained a symbol of the dynamic nature of science. In many ways, the story of Pluto is a metaphor for the changing landscape of astronomical knowledge. As technology advances and our understanding deepens, new discoveries challenge old ideas. Pluto's reclassification serves as a reminder that scientific classifications are not always set in stone, and the study of the cosmos is a never-ending process of discovery and revision. Even though Pluto is no longer considered a planet, it remains one of the most beloved and studied objects in our solar system. The discovery of Pluto by Clyde Tombaugh in 1930 was a milestone in the history of astronomy, and its legacy continues to inspire both scientists and the general public to explore the mysteries of the cosmos. The discovery of Pluto is a testament to the power of curiosity and persistence in science. What began as the search for a theoretical ninth planet turned into one of the most fascinating chapters in the history of astronomy. Clyde Tombaugh's discovery, the subsequent naming of Pluto, and its eventual reclassification as a dwarf planet have all contributed to our understanding of the solar system and the universe. Pluto's journey from discovery to controversy and, ultimately, to renewed fascination serves as a powerful reminder of how science constantly evolves and how our understanding of the universe is ever-changing.